Hi everyone, welcome to the Homework 2 review video. I'm going to start off with Homework 2 question 1, creating sequences. So I'll start off by copying the code that's provided in the script window, paste it into my editor window in the MATLAB editor, and I'm going to save my question. So I'm going to save it as Homework 2 question 1, creating sequences, and I'm going to save it. So let's take a look at part A. So part A is asking me to create a row vector named vec1, which has this following sequence. And this sequence is broken up a little bit further. It shows me that 8 is 4 multiplied by 2, 20 is 5 multiplied by 4, etc. So let's visualize what this sequence looks like before we start coding it. So basically a sequence is comprised of two things being multiplied together. So for 8, we can see that it's 4 multiplied by 2, and when we go up to the nth term, it is n multiplied by this expression here, n minus 3 times 2. So let's take a look at the first number in the sequence. So we're starting at 4, then we go to 5, then 6, then 7, and then we go all the way to n. So what does that mean when we're trying to write out that first term being multiplied in our sequence? We know that we're starting at n, and we're starting at 4, and we go all the way to n. So and we're using a step of 1, since we go 4, 5, 5 to 6, 6 to 7, that's all a step of 1. So how we can write that is 4 and then colon n. Since we're starting at 4, going all the way to n, and using a step of 1. And then we need to multiply that by something. And we are going to be doing, since this is a vector, right? This vector is a 1 by n minus 4 vector. And so we need a vector of the same size. And we can do element-wise multiplication because we want another vector in return that has this sequence. And so now looking at the second element in the multiplication that's happening in our sequence, so we're starting at 2, and then we're going to 4, and then 6, and then 8, all the way until n minus 3 times 2. So this is having a step of 2, and we're starting at 2. So we're starting at 2, we're going with a step of 2, and we're ending at, what we end at is just this value. This last term in our sequence shows us what that last number is and shows us what two things are being multiplied. So we want n, the last number or the last term in this vector, to get multiplied by the last term in this vector, which would then be n minus 3 times 2. And we want these two to have the same dimensions, which is why we don't end at n, we're ending at n minus 3 times 2, since that will give us the same dimensions for these two vectors. So let's write that in MATLAB. So we want this, this vector to be named vec1. So I'm going to call it vec1, and it's going to be equal to, we're going to have 4 to n dot times 2 to 2 with it, right? So we're starting at 2, taking a step at 2, and then we're going all the way to n minus 3 times 2. Okay, let's take a look at part B. So part B is asking us to create a row vector, which is copied from vec 1 and removing the values 8, 56, and 108. So we want to copy vec 1 from vec 2, and then we want to remove some elements. And so we know that 8 would be the first element in our sequence, and then 56 would be the 1, 2, 3, the fourth element in our sequence, and then 108 is the 1, 2, 3, 4, 5, 6th element in our sequence. So what we can do to remove those is we have vec 2, and then we can access the first, fourth, and 6th elements of vec 2. I need my square brackets to access those, and then I'm going to set it equal to an empty set, and that will remove those elements from my vector. And so now we've removed the numbers 8, 56, and 108, sorry. The next question is create a row vector named vec3, which has this following sequence. So let's take a look at this again to write out the next vector. So in this next case, we have again two things being multiplied in any sequence, and we have here n to the power of 2 being multiplied by 1, then we have n minus 1 to the power of 2 being multiplied by 2, then n minus 2 to the power of 2 being multiplied by 3, and then all the way to 1 to the power of 2 multiplied by n. And it gives an example here when n is 10, what this would look like. So we can't just start at, 100, like in this case when we started at 4. We can't just start at 100 and then go down to 1, because it's going to change depending on what n is. So we can't just start at these numbers. We're going to have to look at this sequence. So in this case, we're starting at n to the power of 2 for the first term in what's being multiplied in our sequence. And it goes all the way down to 1. So we know how to write that, n going down to 1. So we know we can write n, and then we do a step of minus 1, and then we end at 1. But this is being squared, and there are actually two ways we can square this value. The first way is by doing a dot exponent. So we can do dot exponent 2, and that will square it, or we can multiply this by the same term. So we can do an element-wise multiplication with, not by 2, because that would just multiply every value in this vector by 2, but we would want to multiply it by itself, and that's squaring it. So these are the two options we have to square it. And then for this other term, so we're starting at 1 and we're going to n, and that's being multiplied to this. So but for that, you can have either of these expressions, and then you would dot multiply by n to 1. And that will give us this sequence. So writing that out in MATLAB, so part C, and we want to write out vec3. And so again, we're starting at n, we're going down by a step of 1 all the way to 1, and then we want that to be squared. And then we want to dot multiply that by this vector, which is 1 to n. And as a comment, I'm going to write out that other option where you can, instead of using an exponent, you can dot multiply this vector by itself. So we're going to do another n all the way to 1, and that will give you the same expression. It's just a different way to square it. Okay, let's take a look at part D. So create a column vector named vec4, which has the same elements of vec3 in order. However, starting from the second element, every fourth element of vec4 is replaced with 0. So let's write that out. I'll write out part D. So first we know vec4 is copied from vec3. And then next, we want to replace some of the elements. So we're going to first refer to those elements that we want to replace in vec4. And it says, starting from the second element, we want every fourth element to be replaced with 0. So we're going to go with a step of 4. So we're starting at 2. We'll go with a step of 4, and then we'll go all the way to the end of the vector. And we want to replace that with 0. And so that's how we would replace that value with 0. All right, now on to the final part, part E. Create a 1 by n row vector named vec5, which has the following sequence. Then the value at the even locations is replaced with 5. So in this case, what we can see is every element is cubed in this case. So we're starting at 1 and we're going all the way to n. So we know how to write that. So we have vec5 so we know how to write 1 to n. But in this case, each element is cubed. And so that's similar to what we wrote up here. But instead of starting at n, we're starting at 1 and going to n. And we want to cube that value. So that's how we would write that expression. So first we wrote out this sequence, but now we want every value at the even locations to be replaced with 5. So to do that, we'll take vec5 and we're going to start at the second location, since that is the first even location. And we want all the other even locations following. So we would take a step of 2, right? Since we're starting at 2, 3 would be odd, 4 would be even. So we take a step of 2 to go from 2, 4, 6, 8, etc. And then we go all the way to the end. And we want to set those locations equal to 5. All right, perfect. Let me run my script in my editor window. I have no errors. I have my outputs. Let me copy it into MATLAB Grader. So I'll copy it here. Let me run my script and submit. Oh, I made a mistake. So here it specifically asked me for a column vector, but I've left mine as a row vector. So how can I fix that? What I can do is when I copy vec3 from vec4, I can immediately transpose this, and then I can still refer to the second element, take a step of 4 to the end and replace that with 0, and that will give me a column vector instead of a row vector. So if I run this again, and if I open vec4, I can now see that it is a column vector like the question asked me. So let me also fix that here. I need to transpose this. I will submit again. And now I passed all my tests. Awesome. Let's move on to the next question. All right, let's take a look at question 2 from homework 2. So first I'm going to copy the given code and paste it into my MATLAB editor. Next, I will save my question. So I'll call it homework 2, question 2, array manipulation. Okay. So let's take a look at part A. So first it's asking us to create a matrix called mat A, which is made of only the even rows of mat 1. So if we look at mat1 is a 15 by 15 matrix that has randomly generated values in it, and we want only the even rows of mat1, and so that will result in a 7 by 15 matrix for mat A. So let's do that. I'm going to type out my part A, and first thing that I want to do is I want to think about how I'm going to access only the even rows for my mat A variable. So I want that to be from mat1, and if we think about the even rows, that would be, row 2, 4, 6, 8, 10, etc. And so to get that, what we can do is, since we want the even rows in the row location when we're accessing, when we're referring to our rows and columns, I'm going to start at 2. I'm going to take a step of 2, and then I'm going to go all the way to the end to access the even rows. And since I want to access the entire row, I'm going to use a colon in the location for my columns. So that will signify I want those even row locations, and I want all of the columns in those even row locations. And that will then give me the full row from mat1 and only the even rows. So I will write that, and then that will give me a 7 by 15 matrix. All right, let's take a look at part B. So part B is asking us to create a matrix named mat B, which is a copy from mat A, then rearrange the elements in the last row only of mat B. The first 5 elements should be swapped with the last 5 elements. Note, the middle 5 elements in the last row of mat A remain in their original positions. And then it gives an example. So first, let's copy mat A from mat B. So I've copied it over there. And then I want to think about how I can swap the first 5 elements with the last 5 elements in the last row. So if I take a look at, this is a 7 by 15 matrix, and I want to swap the first 1, 2, 3, 4, 5. I want to swap the first 5 with the last 5. So in my matrix, this would be elements 1 to 5, and this would be elements 11 to 15. And I want to swap them. And if you guys remember from your from one of the examples in lecture 2 about swapping columns, one way we can do that is we can refer to these columns within our code and then equate it to them swapped, and that will swap those columns or elements for us. So what I mean by that is we can write it out like this. So if we have mat B, and we just want to swap the elements in the very last row of mat B, so we're just going to access the last row, and I can do that using end. And I know I want to swap the 1st to the 5th and the 11th to the 15th. And I want that to equal to mat B, again, just the last row. And I want now the 1st to the 5th elements to be equal to the 11th to the 15th elements. So what I can do is I can write my 11th to 15th elements here, and I want the 11th to the 15th elements to be equal to the 1st to the 5th elements. So I can write that like this. And what this is doing is it's saying, in my last row of mat B, I want the 1st to the 5th elements to now be equal to the 11th to the 15th elements, and I want the 11th to the 15th elements to be equal to the 1st to the 5th elements. In your lecture video, you may have done this with just one element. So maybe you just said the second and the third are now become the third and the second, but we can also do this with multiple elements like the way I've shown here. All right, let's move on to part C. So part C is asking us, create matrix C, which is a copy of mat A. Edit mat C so all the values in the odd positions according to linear indexing are equal to 0 except for in the first column. So the first column will remain unchanged, but then all the other odd elements according to linear indexing should be 0. So first let's copy our mat C from mat A. And then let's take a look at our matrix again to kind of visualize what's happening. So according to linear indexing, our odd elements would be, so here this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so on. But we don't want this first column to be changed. We just want the odd elements in the rest of the matrix to be set to 0. So what we can do is first we can create a temporary variable that contains the values in this first column. We can then edit the whole matrix, accessing the odd elements, setting those equal to 0, and then we can replace back this, this column again. And then after, I'm going to show you a second way to do it, but first let's start with this method. So what I'm going to do is first I'm going to create a temporary variable that contains the first column of my mat C. So this is the column we don't want to change, but what we're going to do is we're going to change it. Initially, we're going to just first set all the odd elements equal to 0, but then since we have this temporary variable that contains that unedited column, we're going to replace it back. So to access that first column, we're going to access all the rows and the first column, and so that gives us the entire first column of mat C. And now we know how to access the odd elements, right? In mat C, if we start at the first element and then we take a step of 2 and we go all the way to the end, and remember this is according to linear indexing, and we set that equal to 0, not equal to, we're not removing the elements, we're just setting them equal to 0, so we're setting them equal to 0. And so here we're starting at 1, and then we take a step of 2, so we're going 1, 3, 5, 7, 9, etc. with the odd elements. But now what we've done is we didn't want to remove the element 1, 3, 5, and 7. We just wanted to start at, this was element 9. And so what we can do is we can, now that we've removed that column, we've replaced the odd elements in column 1 with 0, we can replace that back with this temporary variable that we saved. So we're going to say mat C, again in the first column, so all the rows, the first column is now equal to our temporary variable, and so we've put back those original values, and we only have zeros in the odd locations starting in the second column. Another optional way to do it is we can think about linear indexing right off the bat and where the odd elements start in the second column. So we know in the first column this would be 1, 3, 5, 7. That means this is 8 and this is 9. And so looking at a visual representation of our 7 by 15 matrix, we know that the odd elements in the second column start at 9, and we can use this to solve this question instead. So another way to do it is, so we're copying mat C from mat A. And I'll just leave these as comments since I've already written my code for it, but this is just another option. And then what we can say is in mat C, we can start immediately at the 9th element, and we can still go with a step of 2 all the way to the end and set that equal to 0. And set that equal to 0. And so in this case, we're starting immediately at the 2nd column using linear indexing, accessing all the odd elements, and then going to 0. So that is another option for part C. Now let's take a look at part D. So create a 2n by n size matrix mat D in which every element is n. And so there are 2 different ways we can do this, but both ways we're going to have to use we're going to have to start by creating a matrix using either the zeros function or the ones function, and then doing some kind of operation to replace those elements with n. And so first I'm going to show you how to do it with zeros. So I'm going to create mat D, and then using my zeros function, I can specify the dimensions I want. So in this question, it asks for a 2n by n matrix. So I'm going to do 2 times n. And remember, you can't just write 2n. You would have to use the asterisk to specify that you're multiplying by n. And then this creates a 2n by n matrix filled with zeros. And if I want all those elements to be n, I can add n, and that will add n to each element of my matrix. And so that will then create a 2n by n matrix full of the value n. So every element will be that. And because n is a scalar, I can just add it and it will automatically add it to every single element in my matrix. Another option to do this is using the ones function instead. So if I create my mat D using ones, and again it's a 2n by n matrix. So now I have a 2n by n matrix that's just full of the value 1. And if I want all of that to become n, what I can do is I can multiply by n. And again, n is a scalar, so if I multiply it, I don't necessarily have to do dot multiplication here. I can just multiply it by n. Since this is a scalar, it will multiply to every single element in my matrix, and it will create my 2n by n matrix full of the value n. All right, let's move on to the last part, part E. That asks us, create vec B that has the same elements as the first row in mat 1, but every element in the even position is removed. So first let's create our vec B. So we want vec B to be the first row of mat 1. So we'll type out mat 1, and then to access the first row, we will have 1 for the row position, and to access the entire first row, we would use a column to signify, or a colon to signify all of the columns, and that will give us the full first row of mat 1. And now to remove the even elements, to remove the elements at the even positions, what we can do is we have vec B. We start at the 2nd element, and we want to go the 2nd element, the 4th element, the 6th element, etc. So we'll take a step of 2 and then go all the way to the end, and we want to remove those. So we will set that equal to our empty brackets, and that will remove those elements. So that's starting at the 2nd element and then going to all the even elements and removing them. Okay, so let's run the script here. Oh, here I have an error message in line 9. So let's take a look at line 9. And I am missing a parentheses. Oh, I am actually missing a comma. So if I run that again, now it will run. I was missing a comma here to separate my row from my columns, which is why I was getting that error message. But now that I put in my comma, I no longer have that error message. I have the correct syntax for this problem. So let's take a look at the dimensions. Mat A called for 7 by 15. My mat A is a 7 by 15. The others should be the same dimensions. We weren't removing anything. So let's copy this and put it into MATLAB Grader. I'm gonna run my script, make sure I don't have errors. Okay, it ran without output. Let's submit it. And all of my values are correct. Awesome. Let's move on to question 3. Let's take a look at homework question 3, which is all about linear indexing and 3D matrices. So first I'm gonna copy the given code, and then I am going to save this as homework 2, question 3. Okay, so let's take a look at part A. So part A asks us to create a variable val A, which is the second last element of mat 1 in terms of a linear indexing order. So let's write out our val A. And we know that if we wanted to access the last element of mat 1, according to linear indexing, we could do that with end. But if we want to find the second last element, what we can do is, since we know that mat 1 is a 4 by 6 matrix, we technically could figure out what the second last element is according to linear indexing and put in that actual number. But what if mat 1 was an n by n matrix and n was some randomly generated number? Then we couldn't figure out what that second last value would be every time. So what we can do instead is we can actually write n minus 1. And so that takes the index of our last element, subtracts 1 from it, and then gives us that second last element according to linear indexing. So this is one way we can do it to find that second last element, and I would say this is a good way to do it because we may not always know the dimensions of our matrix, and so this way we know we are in fact getting that second last element. Let's move on to part B. So this is asking us to create a vector called vec_b, which is a 1 by 8 row vector containing every third element of mat 1 with a reverse linear indexing order, so starting from the last element. So let's write out our variable vec_b, and we know we want to start at the last element, and we want every third element in that reverse linear indexing order. So we know we're going to start at the end, and we know we want every third element. So what we will have to do is we will have to take a step of -3. So normally, if we're starting from the beginning, if we're starting from 1, we would take a step of 3. And you may have seen before, taking a step of -1 if you're starting at the end. And then in this case, we can go in that reverse linear indexing order with a step of 3. But since we're starting at the end, we would want to use a step of -3. And we want to go, use every third element until from the end to the beginning. So if we go end, we take a step of -3, we go all the way to the beginning. That will give us every third element starting from the end. Now let's take a look at part C, which is asking us to create a variable called vec_c, which is a 1 by 24 row vector containing only the odd numbers from 1 to 47. So in this case, we need to actually create our vector. This isn't being copied from mat 1. We're not reshaping mat 1. We need to actually create our vector. And we know we can create vectors by using the colon operator and different steps. And so what we can do is we can write out our vec_c variable. Normally, let's say we were writing out a vector that was the numbers 1 to 47. So if I just wrote out 1.47, and I won't put my colon and I'll run this, here we can see I have a vector that is the numbers 1 to 47 in order. And that's how I can create a vector. But in this case, it wants me to create a 1 by 24 row vector that contains only the odd numbers. And what we can do to generate only the odd numbers is, again, we can start at 1, and then we can use a step of 2. And that will give us the odd numbers from the range of 1 to 47. So that'll go 1, and then it'll do a step of 2, so it'll go 1, 3, 5, 7, etc., as is shown here, all the way to 47. So if I run this code again, now I can see before what my vector looked like. This was a 1 by 47 vector, just containing all the numbers from 1 to 47. And now I have a 1 by 24 here, as you can see, my vec_c is a 1 by 24 double that contains only the odd numbers from 1 to 47. And so that's how we can create our new vector and make sure it contains only those odd numbers. Okay, let's take a look at part D. So part D is asking create a variable mat_d, which is a 4 by 6 matrix reshaped from vec_c in linear indexing order. So for this, we simply just have to use the reshape function. So we'll write out our mat_d, we'll write out our reshape function. We want to reshape vec_c, so we'll type out vec_c, put in our comma, and then we want it to be a 4 by 6 matrix. And so I'll type that in. And so that is how I can use my reshape function to reshape my vector c. Again, vec_c here is just a 1 by 24 row vector, and so now I'm reshaping it into a 4 by 6, which we know can happen because they have the same number of elements. This has 24 elements. This also has 24 elements. Great, let's go to part E. mat_e is a 4 by 6 by 2 3D matrix that concatenates mat_1 and mat_d in the depth direction. So to create our 3D matrix, what we can do is we can first initialize our 3D matrix. We can just create a 4 by 6 by 2 matrix full of zeros to begin with to initialize that, and then we can assign the first layer to mat_1 and the second layer to mat_d. So what I'm going to do is I'm going to write out my mat_e, and then I'm going to use the zeros function, and I'm going to create a 4 by 6 by 2 3D matrix. So this is initializing my 3D matrix. So if I run this script and I open up mat_e right now, we can see my first layer is a 4 by 6 matrix full of zeros, and my second layer is also a 4 by 6 matrix full of zeros. So now that I have my two layers of my matrix, I can assign the first layer to mat_1 and the second layer to mat_d. So what I'm going to do is I'm going to type in my mat_e, and then I'm going to reference the first layer. So to do that, what I'm going to do is I'm going to say I want to access all the rows, I want to access all the columns, and I want to access the first layer in the depth direction. And I'm going to set that equal to mat_1. And now if I run my script and I open up my mat_e, we can see that my first layer here is my mat_1, and I haven't assigned anything to my second layer yet. It's still just my 4 by 6 of zeros. And if I open up mat_1, we can see this matrix is the same as what is in my first layer right now. And now I'm going to do the same to the second layer. So I'm going to type out mat_e. I want to access the second layer, so I'm going to go all rows, all columns, and the second layer in the depth direction, and I'm going to assign this to mat_d. That is what I want my second layer to be. I'm going to run my code, and as you can see here, mat_1 is now my first layer, and if I open up mat_d, this matrix is now my second layer. And so that is how I've created my 3D matrix. I first started with, I initialized it with zeros, and then I assigned the first layer to mat 1 and the second layer to mat D. So now the next question is asking me to create val f, which is the element located in the second row, fourth column, and second layer of mat E. So I'm going to type in my variable val f, and what I'm going to do is I'm going to access in mat E, I want to access the second row, so this would be the second row, the fourth column, so I type 4, and the second layer, so I type 2, and that is the element I want to access. So if I run my code, I see my val f is 27. Now let's check to see if this is right. So I'm going to open up my mat E, and I said I wanted the second row, the fourth element of the second layer, which is in fact 27. So that's how I've accessed that element within mat E. Now I'll go on to the last part, part G, which is asking me to create vec G, which is an 11 by 1 column vector containing all the elements from the 3rd to the 13th elements of the first layer of mat E according to linear indexing. So what I'm going to do for that is I'm going to type in my vec G, and I'm going to set that equal to mat E. And I want the 3rd to the 13th elements according to linear indexing. And what I can do is I can simply type my 3 to 13 because it's asking for the first layer. By doing this linear indexing syntax, MATLAB is automatically going to assume that I'm accessing that first layer. So I can simply write it like this. And if I run this code, I see, oh, I've gotten a row vector, but this was asking me for a column vector. So this is a 1 by 11 row vector, but this one's a column vector. So what I can do for that is I can simply transpose this. And that will then give me my 1 by 11 column vector, which is the 3rd to 13th elements on the first layer according to linear indexing. Okay, excellent. So I know that my code runs, so now I'm going to copy it, and I'm going to paste it into my MATLAB reader. I'm going to run it to make sure I get no errors, and I'm going to submit it. And perfect, I passed all my tests. So let's move on to question 4.